Hi everyone, my name is Megan Farraher and I will be discussing the new diagnostic test used for Dorchester's disease. As most of you know, Dorchester's disease has quickly plagued our nation. Until recently, there have only been one way to test for this disease. It required imaging that used intravenous dye. This new diagnostic test will be cheaper, safer, painless, and less invasive than the previous test. We did a population-based study recently to find out how the diagnostic test would do in confirming the presence of Dorchester's disease. This chart shows the results of the study. The corresponding letters in each box are there to show you how the calculations are done. The sensitivity was calculated at 91% with a confidence interval of 14.96 to 15.20. This calculation was derived by dividing the amount of people with the disease who tested positive for the disease by the total number of people with the disease. A sensitivity of 91% means that there is a 91% chance that there will be a positive test result if the disease is present. We are 95% confident that this number falls between 89.38 and 92.45. Specificity was calculated at 15.78%. By dividing the total number of people without the disease who tested negative by the total number of people who did not have the disease. There was a confidence interval of 15.01 to 16.57. There is a 15.78% chance that a test result will be negative when the disease is not present. This means that there are a lot of false positives. The positive predictive value was 14.96, with a 14.72 to 15.20 confidence interval. This was calculated by dividing the number of people with the disease who tested positive by the total number of positive tests. This means that there is a 14.96% chance that a disease is present when there is a positive test result. This number could be low because of the low prevalence rate of the disease among the population sampled. Of the 10,000 in this study, 14% had the disease. The positive predictive value is also low due to the likelihood of a false positive. The negative predictive value was 91.50% with a confidence interval of 90.05 to 92.76. This means that there is a 91.5% chance that if the test is negative, the disease will not be present. What we learned from this study is that the prevalence of disease has an impact on the positive predictive value and the negative predictive value. Because the prevalence is low, the PPV is low and the NPV is high. Because the test often yields a positive, we are able to rule out the true negatives as being accurate. Additional screening may have to be considered when there is a positive test result due to the low positive predictive value and the high sensitivity. We can increase the specificity by increasing the threshold we use for testing. This would decrease the sensitivity and bring the two values closer together. Thank you for listening, and we hope you will consider using this new diagnostic method when testing for Dorchester's disease.